Good morning. And yes, there is radio emission from Uranus. This was the strongest event, was observed. We were about 270 Uranian radii out at the time it was observed on the 19th. There was a second weaker event observed by the plasma wave instrument here, and the planetary radio astronomy instrument observed an event at this time.
Brad Smith is next.
Okay, we have 4 clouds in here, and I'll just have to show them to you because, again, we're talking about very, very low contrast phenomena. You can see how difficult these things are to see, and you might, for example, say, well, is that a cloud? No, it isn't. How do we know these are clouds? Well, because we look at them in time lapse, and we see that they move from frame to frame exactly as one would expect for the combination of the planet's rotation and the winds that are blowing on the planet. And to give you an indication of what that motion actually looks like, we have a time-lapse sequence of orange frames, and you can see this motion. It's evidence of Uranus rotating, essentially.
If we assume that the north magnetic pole of Uranus is pretty close to the north geographic pole, then is Uranus revolving or rotating the same direction as Earth is, or is it rotating retrograde?
Well, if you, it's hard. If you look at Uranus,
Yeah.
right? Let me turn around so I look the same way you do. There, we'll get it right. You see Uranus rotating that direction, the same direction all the satellites and presumably the ring particles orbit. So that's what you'll observe.
Well then, if we were looking down at the Earth from the top, would the Earth be rotating in that same direction or backward?
The Earth would be rotating in that same direction as observed from the top.
Okay.
Is there any way of telling from the time-lapse sequence that you showed what the speed of the clouds is, how fast the winds might be moving the clouds?
What we measure is the speed of a cloud across a disk, but that is a combination of the actual rotation of the planet with a wind superposed upon it. In order to disentangle this, in other words, to get the actual wind speed, we need to know the true rotation period of the planet. And that's what the radio observations are all about.
Any early ideas yet of what the size of the clouds is or what the content is?
There are possibilities which we have considered. Methane ice is a possibility. There may also be volatile hydrocarbons in the atmosphere, and these might condense out at the levels that we're seeing. I think the clouds that we are accustomed to, that we've been seeing on Jupiter, ammonia and ammonium hydrosulfide, are likely to be buried so deeply in the atmosphere that we wouldn't see them.
What are the absolute critical times for all of you in terms of knowing the spacecraft is on the right course and knowing that you've done it right? When will that really be happening?
We will, to the best of our knowledge, when we send those commands up at 1 in the morning, know that everything is going to come out right. Okay. We will, a round-trip light time later, know that the spacecraft has received those commands, and we'll see evidence of that on the ground. That's 5.5 hours after that. This is getting almost as complex as the poles. And then what you have to do is kind of follow your timeline, because some of the actual observations, like the Miranda one that I talked about, they are going to be recorded and won't be played back until the next day. And the reason they're recorded is because we do this thing called image motion or target motion compensation, move the spacecraft that causes the antenna to go away from the Earth. We can't receive it. It goes on the recorder, we get it the next day. So I don't know what more to say than that. There's
Just to be sure I understand, you're saying that it's at 1 o'clock precisely that you will be sending up the final critical commands?
very close to
And then at 3:45, a.m. locally, you presumably will, no, that's when the
That's
spacecraft
when the
receives
spacecraft
it.
sees it.
So 3:45 a.m. plus 2:45, you will get confirmation that the spacecraft has received it.
Right.
And at that moment, presumably you will know.
We know that the right stuff is on the spacecraft, and if the spacecraft does everything that it has been told to do, we're going to be right on.